of the DePaul University. This is my assignment of the ellipse. First of all, I just represent my assignment by the running the code with the different two values for the simple case and for the complex case. I already mentioned the value in the boxes for the P1 and P2 for the E1 ellipse and E2 ellipse, and also I mentioned the value to the two different value for the complex case. So for this values, the answer is gone for the 12 of the simple case, and the area of the overlaps for the complex case is a 10. And also I also change the value from the different value, and I also different number for the simple case as well as in complex case. So let me check for the different numbers which are in the, right now is a 404 for the main line. Right now I'm just change the number for the both case like complex and different. So right now the number is 4 or 3 is a point 2, and point 1 is a 1 or 2, and the main line is 4 5 and 5. So let me check from this. The answer is the, yeah, I got it. The answer is 10. The simple case, the overlap area is almost 10, and in the complex case, is the overlap area is 8. So let me explain my code. First of all, there is a point. The class is point and is represented in the 2D space for the self x and y. Now I'm looking forward to the class of ellipse. For the that, I just represent the and the ellipse with the two focal and major axis length. For the self one is focus one and self two is a focus two, as I mentioned here. And for the major, I just access self A is my major X, and self major axis of self C and self B is my maths. It's my maths focus. It's a complex kind of equation for that. So after moving for the checking of contents, check the if the given points lie inside the ellipse, it will be like this for the D1 and D2, and I also mentioned from D1 D2. And my main part is that's compute all of the ellipse is that E1 and E2 num space of 1,000. So if I mention that we can I can I can think that about that imagine we throw the 1,000 of random dots, and if the 3,000 for inside the both ellipse, the overlaps is about the 30% of the bounding box. So I just mentioned the same logic for the Monte Carlo method. Here I also mentioned that x minimum, y minimum, and x and y maximum. So the main accept and reject loop, if the x is random from the uniform and its y is from the random. So I just mentioned the two both of things sets, and if the E1 is content and E2 is and E2 point is also content. So the count inside from the plus one is equal to one. So this is the main accept of reject and loop.